unfortunately, one of our speakers had to cancel, and normally there would have been a talk by Thomas Kotruba, but he's ill and he had to cancel. So now we will have Holger Woltersdorf instead, who will talk to us about the async PHP requests. Holger is also a member of the PHP user group in Dresden, or the founder of the PHP.
Co-founder, yes.
Co-founder. And he also organizes the PHP Dev Days in Dresden. So please go ahead, Holger.
Thank you very much. Yeah, as you said, my name is. Thank you. My name is Holger. I'm working for Fortune Globe. We are doing e-commerce for the fashion industry. You can find me on Twitter and on GitHub and on several other places. As he mentioned, I'm running the PHP user group, or at least I'm one of the runners of the PHP user group. So, and today I want to talk about PHP and asynchronous requests. And PHP and async always was kind of love-hate relationship, because asynchronous requests are not built into PHP. So not really. So to demonstrate the whole thing, I chose a very simple use case. Let's consider we have a PHP creation, PDF creation service, which basically on management level looks like this. Yeah. So the user sends a request to the web service, and the web service creates 3 PDF files. So if we have only 3 PDF files, we can produce them sequentially, which is kind of okay because it's not consuming too much time. But what if we have a lot of PDFs that we have to create in the same time? If we do that sequentially, so we have to create 9 PDFs now, that probably will take a lot of time. And it's maybe not fast enough for the user and for your web service and everything. So what we are basically doing or need is we need to parallelize those requests or those creation of the PDF to make it faster for the end user, because we are doing multiple jobs at the same time. So let's look back. How did we try to do asynchronous requests in PHP in the past? So I have some code snippets. Please take them funny, because they are. We did something like that, right? Create PDF, def null, throw it away. We can do the same thing with shell exec or proc open. It's basically all the same thing. That works since PHP 4. Yeah, so even if you run very old PHP, you can do that. So that works, of course, but we have a lot of downsides here. First, we need to call the script in CLI mode, which is a completely different environment than our web service. If we have a long command with a lot of options for the PDF, that command gets quite messy. Data handling is based on the argv from the CLI, and we don't get any response back because we are sending everything to dev null. Try that on debugging, especially in production. So let's do some HTTP because everybody can HTTP, right? So next thing is we are doing curl request, same script. And the clue is here the timeout millisecond 1. That makes it really send asynchronously. So the curl is coming back here and closes after. So the script is running and the curl resource is closed. So basically it's the same behavior. We are sending everything to dev null because we don't get any response back. So the problem here is we have a web server involved because we are sending an actual HTTP request. The web server can be overhead, of course, because HTTP has some overhead, and can also be an error source when it comes to debugging. So maybe even a load balancer is involved. So you have another system in front of that. So you have 2 environments that you have to maintain, at least. You need the curl extension in PHP. Again, the response is thrown away, and the called script must be exposed under the document root. So that could be also a security issue, depending on the job that you are doing in the background. In this case, when you want to call it over an URL, you have to expose it to the web server. So we also tried very hard doing async stuff by just building up queues, right? So just put that script in the queue and then create a cron tab that is running every minute and is running those scripts. So of course, also that works, but you don't have on-demand execution. So it's not suitable for web servers, of course. It needs a lot of locking and logging because you have concurrency and you need to show what is happening in the background. Yeah, you easily have race conditions, and you also can have, yeah, if one of those jobs is running, is going wild, you can have fun because, yeah, like I said, it's running every minute. So, yeah, your server is maybe soon very dead. So, and you also have a heavy database load because you're technically you're using technically elusive data, which is a bad idea, of course. And you have to maintain something outside of your PHP project, the cron job. So you have to go or have to access some DevOps material. And of course, this is hard to test in the scenario of creating multiple jobs at the same time. So yeah, we also try to be clever, doing something like this. Register a shutdown function, doing a redirect, and the shutdown function is running after the redirect. Also works, but again, there's a web server involved. We have no response. If something is running in the shutdown function, you will have memory leaks, and you cannot throw exceptions in the shutdown function because there is no exception handler anymore, which also is a pretty bad idea. Yeah, and you have no execution time limit because you're already in the shutdown function. So please don't try to be clever. Yeah, of course, there were a lot of people wrapping their head around asynchronous and multi-threading. So there's the extension called pthreads. And when you look at the requirements of pthreads, you see that you need to enable the Zen's thread safety, VTS, which must be enabled on PHP build time. So if you have a standard PHP installation, that is not enabled. And thus you are not able to install or run pthreads. And pthreads are only for CLI-based applications, so no web environment, and there's a big warning that you shouldn't use it in web environments. So it's not very suitable for our use case. So again, it needs a custom PHP build. Not all extensions are thread safe. So when you enable the thread safety, you may have problems with other extensions in PHP because not all extensions are thread safe. Yeah, it's not working in web environment. You have to have a basic knowledge about multi-threading because pthreads is really multi-threading. And yeah, probably you can leave out the basic because you need knowledge about multi-threading when you use pthreads. It's very complex. Yeah, you have a lot of feature and config overhead for such a simple task like an async request. Yeah, and you have to handle the complete process and thread management yourself. So there's also another extension which is called process control or PCNTL that you can install. Again, you need to build PHP with a flag called enable PCNTL. Yeah, and it only works on Unix. So no Windows, sorry. So it needs a custom PHP build. It's not working on Windows. So everybody who's developing on Windows machines cannot use it. you also need basic knowledge about Unix processes here. And the complete process management itself is up to you. So you have to fork things, catch them again when they are finished. And there's another option, which is called Gearman. I think it's a little bit older already. Yeah, that extension has a lot of requirements because you need libgearman, you need libevent, you need UUID, and you need a Gearman server. So you need a completely other piece of infrastructure, plus a PHP extension. So again, a lot of overhead and a lot of configuration that we have, and a lot of setup, especially on development environments, to get that up and running. So what do we actually want? We want to make asynchronous calls to PHP, obviously. Eventually, we want to get the responses of those calls. We don't want any additional infrastructure. We don't want any additional extensions. We would like to have web-like request data handling because we're used to it. So when we are on a web service, we don't want to switch to CLI mode, right? We want to take advantage of opcache because when you have a web request, opcache comes into play. On the CLI mode, opcache is already always disabled. Besides you enable it especially, but usually when you use CLI mode, you don't have any opcache. So our background workers should not be exposed to the public. So that's the point from the slide before. And we want to have some kind of tunable process management. Okay, now what if I told you that we have a bulletproof process manager already shipped with PHP? Yeah, and you're probably already using it. So who's using PHP FPM? Who set up a PHP FPM by itself? Okay, good. So yeah, we are talking about PHP FPM. It's the PHP FOSDEM process manager. So how it usually works when we are doing simple web requests is we have a web server, Nginx or Apache or something like that, which is talking to PHP FPM via FastCGI protocol. And the PHP FPM has a default pool called www, sorry, which spawns 1 to n processes. So that looks like this. So most of the time we have a master process, and this is the default configuration. Yeah, and three worker processes that are waiting for requests. So the initial idea of this talk and the library that I will introduce in the next slides came from a talk by Arne Blankertz in the PHP International PHP Conference in Berlin. He was showing a JavaScript application that was talking to PHP FPM by a library called JS FastCGI whatever. And I said, okay, why can JavaScript talk to PHP FPM but we can't? Because we are doing PHP, right? So I had a look on GitHub if there is a PHP library that can talk to the FastCGI client or is FastCGI compatible and can talk to the PHP FPM client, a server. And I actually found one from Pierre-Eric Charon. And it was from 2005 or 6, I think. It was not maintained for a couple of years. And it was also missing, from my point of view, missing some important features. So that was the point where I started to write or to rewrite the whole library. So there's still original code from Pierre in that library, and he's still in the authors list. So, but yeah, I think 90% of the code is new. So because this library was PHP 5, this is 7.1 upwards. So it works from 7.1 to 7.3. Yeah, I recently released 2.5.0 last week with a little bit better error handling. And yeah, it's quite accepted already. So what does this library do? Let's talk about those FPM pools. First thing that we had on the slide was we don't want to make our scripts that run in the background public, right? So and we also want to have it in an isolated process running. And FPM gives us the possibility to create one or more pools, which are isolating resources for us. So what I can do is I can define a background pool, which is configured to have no processes when it starts, and can spawn up to n processes. Yeah, depends on how I configure it. So I will show you a config later. So what does PHP FPM do? PHP FPM sends the request to the pool, and the pool is queuing the request, some kind of, and when the request is handled, it returns the response back to the PHP FPM, and the PHP FPM returns the response back to the, in this case, the web server. So this is how this background pool looks like. This is the minimal configuration. So we say this is the name, the background. We need to set user and group for permissions, also for the listening permissions. And we can choose if we use a local socket for the communication or if we use a network socket. So we can also do a network socket and a port. So we can also listen to port 9001 or something like that. So the default pool is listening to port 9000, which is pretty cool because Xdebug is listening to the same port by default. Yeah, and what we are doing here is there are different kinds of process managers that you can adjust here. And when you say my process manager is the on-demand manager, then you won't have a master process and no child processes when this pool starts. So the default value is dynamic, and dynamic says, okay, we have a master process and we have child processes waiting for requests. So, and we say, okay, you can have maximum 100 children, and you should close your children after 10 seconds of idle time. So that is basically all we need. You just put that file in the configuration folder confd of PHP FPM and restart PHP FPM, and you're good to go. So when you are using the client now, so this is the library now, we'll just open a new Unix domain socket with the same path that we had given in the pool configuration. Yeah, that's the only thing that you need. We have read and write and connect timeouts here that are default values, so you don't have to give them. And then you just create the client. So like I said, you can do the same thing with a network socket, which is just another class. Yeah, and just give it an IP and a port. So yeah, that would be the config for the network socket. So it's basically the same thing. And now after we created the client, yeah, we just can send a request to a specific file on our PHP FPM server. So very important is that file path here. It's like the script file that you have, or that is your Nginx calling on your PHP server. But you don't have an Nginx, and you don't have document root. How is it called? Yeah, document root is not replaced, so that must be an absolute path with no path traversal in it and no relative path. So it must be an absolute path on your server. Otherwise, PHP FPM won't found it, because PHP FPM has no clue about any document roots or something like that. So it just needs to find that file on your file system. So yeah, there's a big hint in the README, because that is failing everyone. Yeah, and then you give the content, which is basically just a URL encoded string. And then you can send a request and get a response and get the body. So in this case, of course, this is a synchronous request. And just to show you how the response looks like. So this is the interface of the response. You get a request ID, you get the headers back, you can ask for specific headers, you get the body, you get the raw response, which is the body including the headers, and you get a duration. The duration is how long did your request took from request to response. So let's send an async request. It's just another method, so send it async. And this async request will give you a request ID back, which you can just print out. So in this case, this is fire and forget, so we don't do anything with the response. If you want to get the response, you can say, okay, send the request asynchronously, do something in the meanwhile, and at the end of your script, just read the response for that particular request ID. And print the body. So I have a short demo later, so at the end. What I, for example, added to the library is callbacks, because that was the first question when I published the library. Hey, why are there no callbacks for responses and so on? Because everybody's using callbacks in JavaScript, and why don't you use callbacks in PHP? Yeah, so you can, for each request, you can add a response callback and the failure callback. So just like you know it from JavaScript, maybe. The response callback, of course, gives you the response back, and the failure callback will give you a throwable, which can be any error or exception. And again, you just have to send a send async request, and you will automatically notified about the your callback will automatically notified. And later on, I also added a pass-through callback, because I had a use case where I sent something to the worker script in the background, and I wanted to stream the output of that worker script directly to my browser. So and that output comes in buffers, of course, because PHP has output buffering. And it's really hard to completely disable output buffering in PHP. Trust me. And that buffer is passed to that pass-through callback, so you can handle on your client side or on your requester side also the output of your worker. So then there are multiple ways to wait for the responses. So if you just wait, just call wait for responses, then your all your callbacks will be notified. And it's basically the same as having a true while true loop, asking if a particular request ID has a response and then handle the response. So I chose to have an inner and an outer loop, so that you can hide everything about looping inside the client. But if you already have something like React PHP or something where you already have an event loop or something like that, you can integrate the client in that loop. That's why we have multiple methods to ask for is our response ready or not. So that is a pretty easy example because it's only one request, right? So, but we have multiple requests in our use case. And what we can do is we can collect all request IDs from the async request, from the request. Can print them out and say, okay, read all the ready responses from those request IDs and print their body. The problem here is that will end up in sequential responding. So the response will look like this. So the first request will respond first, the second, and the third, and so on. So no matter how long each worker needs to do their job, the responses will come in the same order as the requests. So that's maybe not that what we wanted, because we want to save time. And if one worker is faster than the other, then he should also respond faster. And that is what we call reactive. yeah, so what you can do is do the same thing, send 3 requests, and you can say, okay, I will wait for unhandled responses, or until there are no unhandled responses anymore, and then read the ready responses. It's the same thing. Again, it's in an outer loop strategy. And that would end up in this, for example. So if the second request is the fastest one, we will have different order of the responses. And overall, it is faster because let's assume the first one is the slowest one. So let's assume in the previous output, when the first one is the slowest one, everybody else, all the other responses have to wait until the first one is finished, and then we'll print their results. And in this case, we will get the second one as first. So this is ordered by response time, and this is exactly what we want. So yeah, like I said, again, this is inner and outer loop, so we can say wait for all the responses, or ask for unhandled responses and handle the ready responses. So you see we have different namings here for wait and handle and read and so on. So always when you see a read method, it tries to read the response directly, and the handle or returns the response, and the handle methods are calling the callbacks. So if you add any callbacks, you will need to have to use the handle methods. So okay, I promised a quick demo. Yeah, so I'm a backend developer, so I suck at frontend, and I just want to show you. So basically, it's the frontend of our web service. I can create a single PDF. On the right side is the output of the PHP FPM pool in real time, hopefully. And it's not working. Yeah. So there's a background pool client that is spawned, and it's going away after a couple of seconds because I told him so. Now we have the example with multiple PDF creations, but in the same order as the requests. So as you can see, we have 21 processes now. Yeah, and it takes some time because there's a random sleep in the worker. So all the requests have a different length. Actually, they're all doing the same thing. So we need roughly 19 seconds. And yeah, let's wait until the workers are going away. And now we have the multi-requests in reactive order. So as you can see, the numbers are not in order. And we need, hopefully, very much less time. Yeah, 12 seconds, okay. Before it were 8 seconds, so it was very a lot faster. Okay, and we actually created, not that PDF. Yeah, woot. So we just created a lot of PDFs in the background. Actually, why there was no PDF is because WK HTML to PDF library sucks. It cannot handle so many requests at the same time. Yeah. So as you have seen, there is very little configuration that you have to do, and probably it's configuration that you already know because you have set up a PHP FPM pool. That library you just have to pull via Composer, and then you can play around with the requests or the responses and can do things in the meanwhile. Any questions? Yes.